So in this next example, we're going to talk about the difference between continuous and discrete graphs in a real-world context. So this situation talks about a local cheesemaker making cheddar cheese to sell at a farmer's market. The amount of milk used to make the cheese and the price at which he sells the cheese are shown. Write a function for each situation and then graph the function and determine if it's continuous or discrete. So we're going to determine if we have to connect the dots or if we keep them separate, or the points, keep them separate. So the first situation we're going to focus on. 1 gallon of milk makes 16 ounces of cheese. So the 16 ounces of cheese I make depends on the gallons of milk I use. So the input is going to be gallons of milk. That's why I used M. And then W is the weight of the cheese. Okay? So I'm going to pick reasonable values for my inputs. Okay? Reasonable values for gallons of milk used. So I could use 0 gallons of milk, and I'm just going to go up by ones. I'm just going to use 1, 2, 3, and 4 gallons. Okay? Now what we've got to think about, and I'm just using the table first, we will write the function rule in a second, but what we got to think about is if I have 0 gallons of milk, I can make 0 ounces of cheese. If I have 1 gallon of milk, I can make 16 ounces, and that's the situation we're given. 2 gallons of milk, 32 ounces. 3 gallons, 48 ounces. 4 gallons, 64 ounces. So the weight depends on how many gallons I use. And if we look for a pattern here, the weight is always the number of gallons times 16. So my function rule is W equals 16M. If you're thinking about this as a graph, you could think about Y equals 16X as the same thing. It's kind of like X and Y points. What I want to use, though, is the variables we talked about. So to graph this, we don't have any numbers on this graph. So I'm going to go 1, 2, 3, 4, 5, 6. Okay? And then my graph, you can decide how you want it to go up. You could go up by tens. You could go up by whatever you want. I'm going to go up by tens. 10, 20, 30, 40, 50, 60, and then so on. So I'm going to graph my points. 0, 0, 1, 16, 2, 32, 3, 48, and then 4, 64. So again, we think about this, using different gallons of milk, I can make maybe a half batch with a half gallon. So this, I would say, is a continuous situation, a continuous graph. I would say we could connect these points, as long as I don't use negative values, okay? So the idea is that we can use a continuous graph because I can use half of a gallon. I can use fractions of a gallon of milk. That's why this one's continuous, okay? The next situation. Each wheel costs $9. So our inputs and outputs, our input is going to be the number of wheels we sell, cheese wheels, and then A is going to be our money we make off of those wheels. So again, I would just go with the standard, 0, 1, 2, 3, 4 for my inputs. I think that's reasonable, okay? And then I've got to think about, if each wheel costs $9, how do I represent that in this table? So if I sell 0 wheels, I make $0. If I sell 1 wheel, I make $9. I sell 2 wheels, I make $18. 3, I make $27, and then 4, I make $36. So my function, the amount of money I make, is equal to $9 times the number of wheels I sell. So it's pretty straightforward, I think. So 0, 1, 2, 3, 4, 5, 6. I mean, it goes out a little further than we need to, but that's okay. And then my values going up, I can really do whatever I want. You could go up by 9s if you really want. I like going up by 10s just because 10s, it's nice and a solid number. I don't like going up by the, 9, 8, 27, or 9, 18, 27, all of that. So what I'm going to do is for this one, I'm going to maybe make my graph go up by, let's have it go up by 6s. I know that's kind of weird. 6, 12, 18, 24, 30, 36. Because then I go 0, 0. One wheel is $9. So it's going to be about halfway in between 6 and 12. 2 wheels is $18. 2 is 18. 3 is 27. So between 24 and 30. And then 4 wheels is right on 36. Now this graph, we're selling whole wheels of cheese, all right? We're making a wheel of cheese, packaging it, and selling it. So this would be a discrete graph. We're not selling half a wheel. We're not selling, discrete, singular. We're not selling half a wheel. We're not selling fractions of wheels. We're selling whole wheels of cheese. That is why I don't connect the dots. That is why this is discrete, okay? So the last example I have here is graphing functions that are not linear, okay? So the absolute value of x minus 4, x squared plus 1. So for this, I've got these points. I am going to choose just x values, -2, -1, 0, 1, 2. And I'm going to use mental math because I think mental math can be something we can use for this. This is remembering the notion of absolute value. So we're substituting in -2. So this means the absolute value of -2 is 2. 2 minus 4 is -2. The absolute value of -1 is 1. 1 minus 4 is -3. The absolute value of 0 is 0 minus 4 is -4. Absolute value of 1 is 1 minus 4 is -3. 2. Absolute value of 2 is 2 minus 4 is -2. So then I go ahead and I graph my points. -2, -2, -1, -3, 0, -4, 1, -3, 2, -2. So this is a continuous graph. It's kind of a V shape, so this is how this is going to look. I'm going to draw kind of a line going one way, line going the other way. That is my nonlinear function. That is an absolute value function. Okay? And then we're going to do the same idea for the next function. I'm going to use the same -2, -1, 0, 1, 2. And now I'm squaring x and then adding 1. So -2 squared is 4. 4 plus 1 is 5. -1 squared is 1. 1 plus 1 is 2. 0 squared is 0 plus 1 is 1. 1 squared is 1 plus 1 is 2. 2 squared is 4. 4 plus 1 is 5. So I've got these points. Now, the thing to notice about these points is that this is not necessarily a V shape. This is what we call a quadratic graph. We're not going to deal with much of these right now. But this graph is more of a U shape. Okay? So mostly what I care about is you filling out the table and doing input-output tables. That's the biggest thing. Okay? So now I'd say you're ready for some practice and then the checkpoint. Make sure that you're communicating with me what you need. If you need something, you can come in to get it. If you feel like you're falling behind and you need to come in to work on stuff, I might be reaching out to you, all right, to bring you in case there's a chance for us to work in person, all right?